All right, rejoining the channel is my former pilot in VF-143, the Puking Dogs, back in the early 90s aboard Ike. He went on to be a test pilot and NASA astronaut. Please welcome back Scott Kelly. Scott, great to see you again.
Good to see you.
You were last on, we were talking about the digital flight control system, deep intel on that particular improvement to the Tomcat. So if folks have not seen that episode, check it out. But now we want to talk about long duration space flight, something you know a little bit about. But before we get to that, let's mention that you and your brother, who were NASA astronauts together. Now, verify this for me, Scott, that part of the deal with you guys being astronauts together was to see what happened when one guy was in space for a long time and then the other guy was not, and how the effects, obviously your DNA is very close as twins, but was that part of the design for picking you guys to be astronauts together?
Not at all. Had nothing to do with it. As a matter of fact, when we were chosen, one of a reporter asked the guy, his name is Dwayne Ross, great guy. He was the head of the astronaut selection office at NASA. He worked there from the Apollo days through, I guess, practically the end of the space shuttle program. And when he was asked by a reporter, hey, did you know you picked two identical twins to be astronauts? Dwayne's response was, no, we didn't pick two identical twins. We picked two highly qualified test pilots. So in the previous time there, no one ever said, hey, you want to do an experiment? Because generally, an experiment needs a large sample group for it to be statistically significant. So you look for experiments where you can get a lot of data. But it wasn't until I was assigned to this year-long flight that I asked the question, hey, I was getting ready for a press conference, the science folks were briefing me, and I asked one of the scientists, the lead scientist for the long flight, I said, hey, if someone asked me if there's going to be any kind of comparative studies on between my brother and I, because we're genetically, really close, and this would kind of be an interesting thing to do, especially since this was going to be the longest an American had ever stayed in space. How should I answer that question? He says, no, we don't have any plans for that. And I was like, okay. So I go do the press conference. No one ever asked the question about any study. Had they asked, I would have said, no, there's no plans. But then 2 weeks later, he comes back to me. He goes, that question you asked? We actually reached out. We started talking about it within our office and thought, well, maybe there could be some longitudinal studies where you're comparing me to my brother to himself, like over a longer period of time. And we could do some kind of genetic or other comparative research. And so they asked a bunch of universities, and it turns out there was actually a lot of interest. And that's where it came from. It came from a question that I asked years after my brother had even retired from NASA. He was no longer working at NASA, which you got to hand it to him. I mean, he did all these baseline data collection tests, and he was a volunteer only. It turns out they actually had to pay him for this work he did, but he was paid minimum wage. So he was the lowest paid government employee while I was in space for a year.
We'll remind the viewers that, as I've already said, you were a Tomcat pilot. Mark was a A6 intruder pilot, which means you are the better pilot, of course. And so, obviously, Mark's been in the headlines lately. You guys just visited Ukraine. And during your time there, Mark tweeted, just left Ukraine. What I saw proved to me we can't give up on the Ukrainian people. Everyone wants this war to end, but any agreement has to protect Ukraine's security and can't be a giveaway to Putin. Let me tell you about my trip and why it's important we stand with Ukraine. And then this troll, random dude named Elon Musk said, you are a traitor, to which Mark responded, Elon, if you don't understand that defending freedom is a basic tenet of what makes America great and keeps us safe, maybe you should leave it to those of us who do. Mark, retired captain, 25 years in, thousands of hours As an attack pilot, fought in Desert Storm, NASA astronaut, served the nation as a senator now for some years. Wife, Gabby Giffords. Your reaction to that comment?
When I read that, my jaw kind of hit the floor. It like fell out of my face. It was kind of hard to put back in, you know. It was just completely shocking, right? Because of all people to call a traitor. I mean, we came from a family of public servants. I mean, our parents were, both our parents were police officers. Both of our grandfathers served in World War II. My brother and I were volunteer EMTs while we were in high school. Later, you know, we both went into the Navy. Mark flew 39 combat missions in the first Gulf War. We both were NASA astronauts, you know, that, you know, were risking our lives. I mean, granted, doing something really cool, but still, you know, you're risking your life for your country. We lost three of our astronaut classmates on Columbia, you know, four other of our friends and colleagues in a very risky profession. My brother's wife, Gabby Giffords, was shot in an assassination attempt while she was a member of Congress, serving as a member of Congress, and six other people killed. My brother now serves as a U.S. senator, which is not an easy job, but it's still, you know, a service to our country. We've been serving, particularly him, our country for, I don't know, 45 years. What has Elon done? I don't know. I think he ran away from conscription in his country when he was of the appropriate age. I mean, he does some great things with SpaceX. I'm a fan of the technology, but I mean, for him to call my brother a traitor is just beyond the pale. I mean, I mean, it's ridiculous.
Yeah, no, I concur, and that one struck me the same way. A segue from Elon to SpaceX. About 8 months ago, our good friend TJ Cooney and I did an episode about the difference between the Starlink space capsule and the SpaceX Dragon when it first became apparent that Suni Williams and Butch Wilmore were quote unquote stuck up there. They weren't technically stuck. If they had to, let's just say emergency sortie, they were allowed to, but there were problems with the thruster on Starliner that over an abundance of caution, they just said, okay, hang out and they thought it could be as much as 8 months. And we'll get you back using Dragon. So that's what happened. Just a little bit to review the bidding. Butch and Suni. Butch is a Hornet pilot, like Mark served in Desert Storm as a legacy Hornet pilot. Suni is a H-46 pilot and a Naval Academy graduate, class of 87. I always like to point that out. She actually ran a marathon in space. But let's review the tail of the tape here. So you are number 4 in terms of cumulative days in space, and you're number 3 in terms of number of days in space on a single mission. And as you alluded to before, you at one time held the record, 340 days, and that was eclipsed by I think Mark first, and then Frank. A lot of this is captured in your book, which, again, I'll put the link to it in the episode description, which also talks about some of our adventures together, specifically a sandstorm in the Gulf of Aden that we dodged.
Actually, Ward, though, the better story is when you put your foot on Snake's helmet because you thought he was a JO and shoved him out of the way.
Yeah, yes, we certainly need to tell that story every time you're on. For the details of that, go back to the first time I talked to Scott some years ago about the how you go from being a fighter pilot to being an astronaut. But yeah, I accidentally kicked the skipper in the head as we were getting out of an airplane late at night.
No, it was very much intentional.
Well, I didn't know it was the skipper.
Yeah, that was the accident. You misidentified the person.
And it wasn't like a kick; it was a shove. I know you want to call it a kick. It was a shove because he's hanging out at the base of the ladder, and we're trying to get out of the airplane so they can get in. But in any case, Scott has been in space for a long period of time over the history of his career as an astronaut. And we wanted to talk about, now that the crew, and let me show some B-roll here. Here's what SpaceX 10, this is the crew of SpaceX that just docked yesterday, the day before, with the ISS, and here they are getting aboard. You can see Butch and Suni hugging them as they get aboard there. It's interesting. There's actually a Russian. Is that correct? Am I seeing a Russian guy there as part of that?
Carroll, I forget his last name, but he came up on the SpaceX. They always have a Russian on the SpaceX and an American on the Soyuz, in case, it gives you redundancy of having crew members aboard. So if one of the spacecraft has an issue, like let's say Soyuz has an issue, they still get to rotate out a Russian on Dragon and vice versa.
Okay. And then here's a little group photo they took. And that's Butch on the far left and Suni there middle back. Now, when Suni was up there a few months ago, she was getting very skinny, and there was some concern that her health was failing. Obviously, as we saw in that B-roll we just showed, she seems to be fine and in good spirits. So I wanted to ask you, what are the effects, and you were in space for longer than 8 months, but what are the effects on the human body that maybe our average viewer doesn't understand?
Well, first of all, I've known Butch and Suni before we were both astronauts, or all three of us were astronauts. Butch was an instructor at the U.S. Navy Test Pilot School when I was a student. I think he got there kind of towards the end of my year-long training. Suni was in the senior test pilot school class. There's always a senior class and a junior class, and she was in the senior class at TPS, so I've known them a long time. I want to comment something about the whole, her looking like she was losing weight. She's always been thin. I was just at my flight physical in Houston, and I was talking to one of the flight surgeons, and NASA wasn't sure where that rumor initiated from. They actually looked into it, and they couldn't figure it out. This whole idea that she was losing weight and it was affecting or could potentially affect her health was not something that came from NASA. But the physical effects. So, there's many. We, as humans, evolved in gravity. Our cardiovascular system, if you use it as an example, our heart and our vascular system is designed to force blood against gravity to our vital organs that are generally in our chest and our brain, right? So when you get to space, in the absence of that gravity, your heart doesn't have to work as hard. Your vascular system doesn't have to be as strong to keep that blood up in our head. So we lose heart mass. I lost 25% of my heart mass on my nearly year-long mission. You lose other muscle mass. Just sitting here requires effort to fight against the forces of gravity. And we need our muscles to do that, and our bones, actually. So when we get to space in this microgravity environment, we lose muscle mass on all our muscles, particularly it's kind of hard to exercise your neck. You never realize how much effort it takes to hold up your head until you're in space for nearly a year and you come back and those muscles haven't been exercised for so long. So if you didn't do any exercise, you would lose about 1% of your bone mass and muscle mass every month, right? So after 100 months, you'd have no bones left. You'd be like a Gumby, maybe, right? So those are kind of the microgravity effects, and when you're in space, your head swells up too, because your body tries to get rid of a lot of this fluid, but for some reason it can't get all of it. And even towards the last day I was in space of my 340-day mission, I felt this uncomfortable, swollen head. It affects your it would kind of, make my sinuses congested, that kind of thing. It actually, we think that it actually affects our vision. Our optic nerve, you can get from that pressure, get swelling of the optic nerve. You can get these things called choroidal folds, which is the back of our retina that nourishes the retina, and you can get these wavy folds in it where the concern is maybe it could cause blind spots someday. And that's, one of the things we're trying to understand. So, those are the microgravity effects, I would say, mostly. Certainly, floating's fun, but makes many things harder to do. So that's another challenge of living in zero gravity. And then there are the effects of radiation. 10 to 20 chest x-rays equivalent of radiation every day. And that can have an effect on our physiology as well, on our genes, what they're referred to, but that's basically DNA, RNA, proteins, basically the stuff in our bodies that make us who we are. Without them, we wouldn't exist. And the radiation can change what's called the expression of those genes. And if you think about gene expression, basically it's just a switch turning it on or turning it off. And depending on what that gene does, it could be, a bad thing or a good thing, maybe. We discovered that there was actually one good thing that, like a positive health experience that I benefited from. And that was, we had an experiment on our telomeres. And telomeres are of our ends of our chromosomes. And as we age, they get damaged and more frayed, they get shorter. It's kind of an indication of our physical age. And there was this telomere experiment, and NASA thought, or the experimenter, the person that it was their study, thought that between the radiation and the microgravity and the stress, my telomeres would get shorter, as in I would age more, I guess, in a telomere sense, than compared to my brother on Earth. And what actually happened is they got better when I got back. And it was like, we didn't expect this. And they thought, well, maybe it was due to the exercise we do all the time and a very controlled diet, that maybe that helped. But about 6 months after I got home from that 340-day flight, NASA realized that the Japanese had a telomere experiment going on the space station at the very same time. And it was on these little mice. Little worms. And their telomeres got better too. And I never once saw those guys like working out on the treadmill or anything. So we were like, there's more to this than meets the eye. But later they figured out it was the radiation. Like radiation can kind of excite and exercise your telomeres so they get better.
What is the source of the radiation? Is it just all of the electronics around you?
No, it's
or is it being closer to the sun than
cosmic radiation? And
so, okay.
Either deep space or from the sun, because the magnetic field of the Earth protects us from that. And when you're above it, or above a lot of it, you don't get as much protection. Actually, on a Hubble mission, and you can see this sometimes on the space station, but it's kind of rare. So it's kind of hard to know what it is when you see it. But you can actually see cosmic rays sometimes. If you close your eyes, you can see these flashes of light that radially go from towards the center of your eye with your eyes closed. A Hubble mission that was much higher, my first flight, we saw a lot of those. And it's kind of like fireworks, which it's a little disconcerting because you're like, well, that cosmic ray, not only is it going through my eye, it's also going through my brain and the rest of my organs. So, radiation's an issue as well.
So when you got back, and we've talked about this in a previous episode, you took Soyuz back home, landed in the Mongolian desert or wherever you came down. What did it feel like? You've alluded to some of the forces that you feel once you get back to Earth, but does it feel very weird when you have gravity again after nearly a year without it?
Yeah, it's you can tell gravity is a strong force in the Soyuz because the way the seat is positioned. It's kind of hard to breathe. It actually shuts off your trachea. Once you kind of slowly feel the G's build up as you hit the atmosphere, but then in the Soyuz, it gets to, I don't know, like 5 G's, and it's almost like you have to lift your head up to breathe. You're just kind of squashed down on the seat. Eventually, the parachute opens, and you're thrown around like crazy. It's like the best carnival ride ever. But yeah, eventually you hit the ground. You kind of crash into the ground. You roll around some, and they pull you out, put you in a chair. You could walk if you had to. I walked about maybe I don't know, like 45 minutes. I did my first walk, and you're dizzy. You're going back and forth. It's a little awkward, but eventually the symptoms start to affect you of gravity. In my case, nausea, dizziness. I've only threw up once after coming back from space, and that wasn't on my longest flight, but it was on the 150 something day mission. When I would stand up, probably the worst thing I had was when I would stand up, my ankles would just swell up like water balloons due to the cardiovascular deconditioning. Also, because you don't sit or have any pressure like on your back of your legs, your butt, your back, your elbows when you're like sitting in a chair, I had kind of like an allergic reaction to that pressure because I had not felt it for so long.
You're breaking out like a rash?
Kind of like hives, yeah, almost like an allergic reaction to the pressure. And yeah, you're tired for a while. You get the blood volume back quickly. They'll give you an IV. You drink some salty water. You get the blood volume back quickly. What you don't get back is the red blood cells you lost in space when your blood volume decreased. So that takes a few months. Emotionally, it's of a challenge. You just did this most incredible thing in your life, and now you get back, and it's like, okay, what's next? That's one of the things you experience. Also, when you're on the space station for a really long time, very organized, very methodical, thought schedule. You always have, exactly what the next thing you're going to do is, unless there's some kind of an emergency. And when you get back, it's kind of hard to get used to that in space. This kind of timeline we use, that it just keeps, no matter what you do, it's just moving, and then you have to do that next thing. But then when you get home and you don't have that, you feel a little bit lost, like kind of directionless, I think, for a while.
So how long will Suni and Butch stay? Are they landing near Texas or Florida? Where are they going to come down? Do we know?
I'm not sure exactly. It depends on orbit, but they'll probably. I think they try to land in the Gulf of Mexico usually.
Okay, and so will they be observed for some amount of time before they're allowed to go home, or how much observation time will take place?
So when I got back after my last flight, it was like 24 hours. We're back in Houston. I went to NASA to do some medical tests, and then I was supposed to go over to the crew quarters and stay there for a few days, but I went home. I'm like, I'm going home. And I lived right down the street anyway, really close to NASA. And I just stayed at home. So whether NASA kind of encourages you to stay in the crew quarters. I'm not exactly sure what purpose it serves, in case you got sick or something. Somebody could be there to help you more quickly. But they'll either stay in the crew quarters at the Johnson Space Center in Houston or go home, right home.
So you mentioned it took a few months to get your red blood cell count back to normal. Are there any longer term health consequences for your time on orbit?
The only thing I notice is that my vision is different than my brother's. I have a distance correction that he doesn't require. And that's, I guess maybe due to the duration of my flights compared to his missions were generally on the order of like 2 weeks, where my last two were much longer. So possibly that. As far as the radiation stuff, I don't know. I haven't gotten any like weird disease that could be based on the radiation that he has not had. So um, hopefully I won't.
We've discussed the future of NASA on a previous episode, and also you just talked about the sort of inflection point that NASA made a few years ago regarding cooperation with Russia and what that does, the decision to involve Russia, where that puts the ISS.
We made some very poor design decisions that put Russia in the critical path to keeping this thing safely in space, and that is the ability to control the space station's attitude. Your viewers know what that is, not altitude, but attitude, with propulsive attitude control. You don't have that on the US side of the space station. So, we could spend hundreds of millions of dollars and take years and build this capability ourselves. That actually we had at one time before the space station was built, but it was canceled due to funding. And we could redo that, but by the time it was done, the space station would almost be done anyway, right? So we had to make this choice. Do we continue to partner with them in space, or do we let the space station just die, basically? And it was a tough choice, but we decided to go with keeping the space station running and partnering with the Russians. But I said, I guarantee you, and I have no position to do this because I don't work in the government, but I can almost guarantee you that we will never, ever participate with Russia, meaning this Russia. Maybe someday there'll be a different Russia, but with this Russia in space ever again.
What's your sense of the health of NASA and the future of space exploration?
If you would have asked me that question a year ago, I'd probably have a different answer than I do now. I don't know what the future is. The Artemis mission, I hope we continue with it. That was one of Trump's programs in his last presidency. So I would hate to see that canceled.
Remind folks what the Artemis mission is.
Yeah, Artemis is to return people to the moon. And there's an Artemis 2 mission coming up probably within the next 2 years, where we're going to have a crew of 4 people fly around the moon, not going to land. And then the third one, the landing will be after that, using a SpaceX Starship as one of the proposals for the lunar landing vehicle. But a lot has to happen before then, including, the Starship being able to actually just re-enter the Earth's atmosphere without blowing up. They got some work to do ahead of them. But, how NASA is funded, managed, what we're asked by our government to do, I don't know. I mean, there's just so much chaos in Washington, D.C. right now.
Well, we missed you guys the last time you were on the East Coast, unfortunately, but I hope we can see you in person before too much longer. Thanks for providing some insights on what happens to the human body in space. And as always, my good friend and former pilot, I look forward to talking to you again very soon.
See you, man. Thanks for having me on.
All right, that'll do it for this episode. If you're not already a subscriber, become one so you don't miss anything. And in the meantime, I look forward to talking to you again very soon.